Hey guys, today we're going to be taking a look at showing you some of the functionality of 2D transformations in the graphics package that I'm building. So in order to get started, we can go ahead and compile the graphics package in its current form and run it using /run. And what you'll see here is a basic command line interface that demonstrates some of the commands for 2D transformations, translation, scaling, rotating, and of course displaying and clearing our screen, as well as some basic file I/O and other important commands that you should know. So to get started, we can go ahead and input some sort of txt file. I have one already prepared here, and you'll see that once we have received file input, we get our graphics package to create the window and display the amount of lines processed. In order to display the contents of that file, we can go ahead and use the D command and get started showing off functionality of the translate command. So in order to do that, we can go ahead and translate in, let's say for now, just the X direction and 0 in the Y direction. We're increasing our X direction here, so we expect this square to move to the right by 100 pixels. Indeed, if we apply and display that transformation, you'll see that our square has indeed moved to the right. If we want to go ahead and clear our screen and display only the new square, you can notice a general shift in the X direction as well. This is, of course, true for shifting in only the Y direction. For example, if we shifted by 100 in the Y direction and 0 in the X direction, what you should expect is this square to move downwards. That's because our origin point at 0, 0 is going to be in the top left. So translating by a higher Y value means that our square moves downwards. And indeed, if we apply and display that transformation, that's exactly what we see. Our original square has gone from up here to down here. Now, we can also move in both the X and the Y directions at the same time. For example, if we moved by -200 in both the X and the Y, what we'll expect is that our current square, which is right here, is translated to be closer towards the top left, so somewhere around here. If we go ahead and translate that, we can clear the screen, display the square in its current form, apply our transformation, and then redisplay our new square, and indeed we do see a shift towards the top left. Perfect, so that should show you basic functionality of the translate command. If we want to move forward and show off functionality of the scaling command, we can do that simply by re-inputting our square.txt file, displaying that to screen, and then scaling. Let's start with basic scaling, which is going to be about the origin here at 0, 0. If we scale by 0.5 in both the X and the Y direction, what we should expect to see is that the square is half of its original length and width, and it moves towards the top left. It gets closer to our origin point. Indeed, if we apply and display this transformation, that's exactly what we see. And we can also do basic scaling in the opposite direction. For example, if we wanted to scale this by, say, 4 in both the X and the Y direction, what we'll see is this square, the new square, is 4 times the size of this smaller square that we have, and it's moved closer to the bottom right, away from our origin point in the top left. Indeed, if we clear our screen, display only our smaller square, apply the transformation, and then redisplay our new square that's been scaled, that is exactly what we see. And of course, this isn't just the case for basic scaling. We can also demonstrate functionality of general scaling. If we go ahead and clear the screen, re-input our square.txt file, display that to screen, and then get started with general scaling, you'll see that I no longer have access to my help menu. If I want that to reappear, I can simply type in H. And we'll see that for general scaling, we use this capital S command along with 2 additional arguments that specify our center in both the X and the Y direction. So in order to get started, we'll go ahead and scale by, let's say 0.25 instead of 0.5 this time, about the center of the square, which in this case is 300, 300. If we apply and display that, what we'll expect to see is a smaller square. It'll actually look a little bit smaller than that. It should be something like that in the very center of our original square. And indeed, once we display that, that's exactly what we see. Now, we can, of course, demonstrate functionality of larger scaling, just as we did before. We'll use scale, maybe this time by a factor of 5, in both the X and the Y direction by our original center point. Apply that, and what we'll expect is a bigger square than our original. And indeed, that's exactly what we get. Perfect. So now that we've demonstrated that functionality, we can move on to demonstrating functionality of rotation. Let's clear the screen, and this time let's input a different text file. This is foo.txt, and as you can see here, it's just one line. Once we display it, you'll see that it looks a little something like this. If we start by demonstrating functionality of our basic rotation, you'll see that all we need is a set of radians, and we'll be rotating about our origin in the top left. Now, if we rotate by only 0.1 radians, what we'll expect is that this line moves this way, towards the right and up, because of that 0, 0 origin point being in the top left and that being our point of rotation. What we'll expect is a line that looks a little something like this. And to test that, we can go ahead and apply this transformation and display it, and indeed that's exactly what we get. We can rotate by any number of radians. For example, if we wanted to rotate this time around by 0.25 radians, we could do that as well. Apply and display that. You'll see that the more we rotate, the farther off screen this line will go, and so we'll stop there for rotating in the basic sense. If we want to test functionality of our general rotation, we can go ahead and input foo.txt once more, display that to screen, and let's go ahead and rotate this using our capital R command. And this time let's rotate it by, say, 1.57, which is approximately pi by 2. Rotate by 1.57 by our original origin center point, which is 300, 300. That is this vertex of the line right here. And what we'll expect to see is that once we apply and display this, this will create a sort of right angle because this is pi by 2 rotations. And of course, we expect that the pi by 2 go this way because of our origin point being in the top left and this being a counterclockwise rotation. Now, with that out of the way, we can go ahead and maybe rotate by 1.57 once more about our general origin point, apply and display that transformation, and we do indeed see that this is rotating by pi by 2. You'll see that these two lines don't match up exactly. That's because we've been using 1.57 as opposed to the actual value of pi by 2, and so we do see a little bit of an error buildup with the approximation there. All right, now with that out of the way, let's go ahead and clear our screen, display our help menu once more, and take a look at all of the other functions that we need to go through. Well, you've already seen me use display lines and clear pretty consistently throughout this demonstration. We've also seen me input a variety of different files. Let's take a look at file output real quick. So if we input a new file, that's just bar.txt, that's going to be just another line, this line looking a little bit different. And let's say we want to translate this line, something super simple. Let's move it by just 100 in the x direction. And then if we clear our screen and display that, you'll see that it has indeed, it hasn't moved because I haven't applied the transformation. Let's go ahead and apply it and then display it. There we go. And then if we want to output that file, we can go ahead and do that as well. Let's go ahead and output it into, let's say, out.txt. We can go ahead and quit. And you'll see that I do now have an out.txt file, and if I want to cat it out, you'll see that what I originally started out with in bar.txt was this line right here, and now I have one line with a transformation by 100 in the x direction. Cool. So with that said, let's go ahead and rerun the graphics package. Let's go ahead and re-input, say, square.txt and display that to screen. One last thing that I want to do in order to demonstrate completely with 100% certainty that each of these functions are working is go through a few of the functions that I've written and sort of display functionality there instead of just using the command line interface. So I'll go ahead and quit the CLI and then open up our main.cpp function. And so here, let's go ahead and demonstrate for sure that general rotation works. And the way we're going to do that is by taking our original foo.txt file, which is of course just one upward pointing line, and then rotating that by 360 degrees. So that should create a circle. And so if we recompile and run, what you'll see here is all of the transformation matrices that we used. And if we input foo.txt, what we will see is indeed a square composed by rotating the original line 360 degrees about the origin, about the center, which in this case was 300, 300. If we go ahead and comment that out, we can also test that our basic rotation works. This is going to be very much in a similar way, except this time we're going to use bar.txt. If you'll recall, that was the diagonal line, and if we rotate that about the origin using our general rotation operator, what we'll see is a full circle. Most of it, though, goes off of the screen, so we'll only be able to see about a quarter of it. And indeed, if we recompile and run, this time inputting bar.txt, we will see exactly a quarter of that circle, the rest, of course, being drawn off screen. Let's go ahead and quit there. We can keep demonstrating some functionality for scaling. And we'll start with the general scale here. We're going to use for this our square.txt file that we used at the very beginning. And if we go ahead and input square.txt, what we'll see is that indeed we were able to take an original square and then scale it both up and down repeatedly, and this works as many times as you'd like. If we go ahead and quit, we can also do the same thing with basic scaling. We're again going to use our square.txt file here, except this time we're going to be scaling it about the origin, so it should get closer and further from the origin depending on how we apply these transformation matrices. And indeed, that's exactly what we see. The square scaling both in and out using basic scaling, so getting closer and farther away from the origin. Perfect. And that should be pretty much it. I didn't include very much else. We do have we don't have pretty much anything else except for a basic translation function, which we can go ahead and demonstrate on screen, but really all of the transformation cases I did cover when talking about the command line interface. If we go ahead and run this, we'll be inputting square.txt for this one as well. And indeed, all we're doing here is just increasing the X and Y translation consistently by 5 until we move off screen. And indeed, that's exactly what we see. Now, I didn't get a lot of time to go through all of the in-depth code for each of these applications, but all of the source code is located on GitHub and in the file submission, so you should be able to access that if needed. Other than that, though, this should be a complete demonstration of all sorts of transformations using the graphics package that I've built, and thank you for watching.